In this video, we're going to take a look at some more examples with finding domain, equations of vertical asymptotes, and coordinates of any holes in the graphs for rational functions. So example 3, part C, we have h of x equals x squared minus x minus 6 over x squared minus 9. So we're going to factor the numerator and denominator. They factor as x minus 3 times x plus 2 for the numerator, x minus 3 times x plus 3 for the denominator. And our domain, if we set x minus 3 not equal to 0 and x plus 3 not equal to 0, we again get x cannot equal negative 3 and x cannot equal positive 3. So at each one of these values for x, negative 3 and positive 3, there's either going to be a vertical asymptote in the graph or a hole in the graph. So let's look at what the graph looks like for h of x here. So here we have h of x, our original problem. Here's negative 3. This would appear to be a vertical asymptote. And at positive 3, it looks like nothing special going on, so there should be a hole in the graph. Oh, yep, there it is. So, yeah, negative 3 got a vertical asymptote. Positive 3, we have a hole in the graph. So if we cancel out these x minus 3's, we're left with x plus 2 over x plus 3. For our first value of negative 3, if we plug that into the simplified result, we get a 0 in the denominator, which again means that we're going to have a vertical asymptote at that value of x for negative 3. There is a hole in the graph at x equals 3, and those are the x minus 3's that canceled out. So we saw that in the graph earlier. The y-coordinate, just plug that 3 into our simplified expression here. So we get 3 plus 2 over 3 plus 3 is 5, 6. So the y-coordinate of this hole in the graph is 5, 6, which is 0.8, and then the 3 is repeating. So a hole in the graph at 3, and then 5, 6. All right, part D, we have j of x equals x squared minus x minus 6 over x squared plus 9. So we change the minus in the denominator to a plus. If we factor this, we get x minus 3 times x plus 2 again on top. And then x squared plus 9 does not factor, at least in terms of real numbers. So we can't really factor that here using real numbers. So x squared plus 9 is actually never going to equal 0 for any real number of x. So our domain is all real numbers. This function, if we take a look at it, we'll hide the previous one. Here's our function. Negative 3, it's okay. It's not going to give us any problems here. So in fact, we get 1/3 in return. Everything else is okay. No holes in the graph. Positive 3, we get 0. And zooming out, there's really no vertical asymptotes there at all. So our function here, the domain's all real numbers, which means there aren't going to be any vertical asymptotes or holes in the graph. So those vertical asymptotes and holes are only for values that in the domain would cause the denominator to equal 0. So it can equal 0, no vertical asymptotes and no holes. So there you go, it is possible. All right, finally part E, we have k of x is x squared minus x minus 6 over x squared plus 4x plus 4. When we factor that, our denominator factors as x plus 2 times x plus 2. Numerator is still the same as it was before. So for our domain, there's only one value of x in the denominator that would cause us any problems, and that's negative 2. So simplifying our expression here, we get the x plus 2's divide out, so we get x plus 3. Oh, I'm sorry, this should actually be an x minus 3 right here. I apologize for that. It should be x minus 3 over x plus 2. We do have a vertical asymptote at x equals negative 2, because if we plug negative 2 in for this expression, we will get a 0 in the denominator, and that causes a vertical asymptote. Looking at the graph of example 3e, we have a vertical asymptote here at negative 2 for x. Nothing else going on, no holes in the graph, not even at positive 2, we don't even get a hole. So only have a vertical asymptote at x equals negative 2, and there's not going to be any holes in this graph. All right, that about does it for this video. Thanks for watching. I'll see you.